Hello, everyone. I'm JP. I'm a tokenomics researcher, and today I'll walk you through a work entitled USDFC and its utility in the Falcon economy. This is joint work between the Crypto Econ Lab and Secure Finance, where we explore how the Falcon economy can benefit from a field-backed stablecoin, such as USDFC, and we also explore and stress test the economic robustness of the USDFC token. Specifically, over the next minutes, we will cover what is USDFC and why does it matter. We will then move to discussing how does this protocol work. Afterwards, we will describe our simulation approach, our risk analysis, and the tests that we did, and we'll conclude the talk with some finalizing remarks. Okay, so let's get started. So what is USDFC? USDFC is a CDP-style stablecoin originally ported from Liquidity's LUSD protocol. If you were in Ethereum in the earlier days, you're probably familiar with them. In short, what happens is that you lock some fill in a vault called a trove and mint USDFC in return based on the amount of fill and its price at the time of minting. This is done with a collateralization ratio of 110%, meaning that you always put more fill than what you can take out, right? And it is worth mentioning that this sort of this is, some people refer to this as algorithmic stablecoins, meaning that they're backed by tokens as opposed to fiat, and rely upon some clever mechanisms for maintaining their peg. So before this, going into more detail into how do they work and how risky they are, let's maybe try to understand what they're useful for Falcon. And Juan just did a fantastic job at saving me this slide, but just for the sake of it, I mean, why building this? Well, first, stablecoins are a stable unit of account, right? It enables dollar-denominated pricing, which can in turn translate into dollar-denominated pricing for storage deals, subscriptions, services, which in turn makes things much easier from an accounting point of view. It can also be used from a liquidity leverage perspective, in the sense that if you are very bullish on your fill, you have a lot of fill, you don't want to sell it, but you need some liquidity. What you can do is that you can deposit your fill in one of these contracts, in one of these troves, get some USDFC in return, go spend your USDFC, then come back, repay it, and you didn't miss out on fill. And if fill is worth a lot afterwards, hopefully, then that's pretty good because you didn't have to sell it. A third advantage of this is that it empowers DeFi on Falcon, right? And that brings more use cases. And as Juan was just showing, this increases the overall value of money, right? Because with a stablecoin, you can underpin lending, borrowing, AMMs, synthetic assets in an economy. Furthermore, as we will see, these sort of mechanisms, they isolate risk in the sense that each individual vault, each individual trove has its own collateral, so it's kind of siloed. And it's also incentive aligned in the sense that Secure Finance recovers fees in fill, hence, empowering the flywheel. And the last point is that, you're locking fill, which in turn reduces the token velocity, it reduces the circulating supply, potential sell pressures, which is always nice. So how does the USDFC work? Well, there's three main components to it. Troves, which are the part that holds the reserve token. Liquidations that mitigate the devaluation risk, the downside risk, and redemptions and arbitrage, which are the mechanisms that are used to maintain the peg to $1. So the way that it works is that for the troves, is that you lock up some fill in your personalized vault, in your trove, right? You can mint USDFC up to your fill's USD value divided by the target collateralization ratio. And then what happens is that if the fill prices dips, your trove collateralization ratio decreases. And once it touches a minimum collateralization ratio, it is flagged for liquidation. So this typical number is 110%, meaning that if you drop below this 110% collateralization ratio, you might be flagged for liquidation. Once you are flagged for liquidation, a bot or some other interested party steps in and can liquidate you. And the incentive by doing so is that they get some funds in return from doing this. And of course, if you liquidate some position that is over collateralized, right, that it's above 100% collateralized, but under the minimum collateralization ratio, the protocol is still safe, right? And you avoid any misliquidation, any being underwater with this, okay? And the reason why this stablecoin maintains its peg is because of the redemption mechanism and arbitrage. So the way that redemption works here is that you can always burn one USDFC to withdraw $1 worth of fill. And the argument here is that this can create arbitrage opportunities in the sense that if USDFC is trading above its peg, right, it's more than $1, this is pretty good because you can always go mint some USDFC and sell it for a riskless profit. That's pretty good. And if USDFC is trading below $1, you can, because of this redemption mechanism, you can always sell it for $1, and again, you're reducing the supply of it, and this pushes the price back up. However, as mentioned before, these ideas are based on liquidity, which is backed by Ethereum, right? So switching over from Ethereum to Filecoin doesn't just change the token, right? We have to rethink the whole mechanism a little bit because the underlying tokens are different. And this creates a few wrinkles here and there. So one of them is the block time, right? So Filecoin has a slower block time than Ethereum. So in this small difference, some things could happen and you might be out of your collateralization ratio, sorry. So you need to be careful with that. The second thing is that there's typically less on-chain liquidity in Filecoin than in Ethereum. And the third one is that even though, as we can see here in this plot, even though they have a very correlated price path, Filecoin has more volatility than than Ethereum, right? So this volatility can in turn translate into like bigger swings in a short period of time, and this can in turn affect the collateralization ratio. So what do we do? How can we be sure that USDFC work? How can we be sure that it's safe? Well, what we did was we did a data analysis and we built a Monte Carlo simulator environment to stress test different market scenarios and different market conditions. And so this simulation environment has four main components. So the first one is a module that simulates a price for fill. So basically what we can do here is that we have this mathematical model that can generate realistic fill price paths using a model called geometric random motion for different market conditions. So you can think of a bullish scenario where the price is pumping, or not so well where it's going where it's trending downwards. And in turn, we can simulate many of these and stress test the effect of these on the other components. Another component of our simulation environment is a Trove lifecycle model. So basically, we model how troves or how vaults arrive to the network, like how often people create these vaults, their size, etc. We have a model for the stability pool dynamics, so basically how often redemptions occur, under which conditions, and these sorts of things. And lastly, we have a model for the on-chain liquidity and for the price of the USDFC. And of course, all of these components are correlated. So what we do is, once we have all these four components, by running thousands or hundreds of thousands of trials under different market scenarios, could be bullish, bearish, high volatility, etc. We map the distribution of these peg deviations, the effect on the collateralization ratio on different effects, and see or test the robustness of the protocol. Okay, so does it work? What happens if we implement? Well, so as I was mentioning, in our model, we have this methodology for simulating different price paths. So each of these lines is a different price path of fill under different market scenarios. So this is a base case, this is a bearish case where the price is trending downwards, this is a bullish one where in about a year fill is worth about $20, which surely is nice, and one with very high volatility, right? So each of these scenarios, we can map it into an effect on the quantities that we want to observe, and we can test how robust they are. So for example, for each of these market scenarios, the base one, the bearish, bullish, and high volatility, we can see how they affect the price stability of USDFC. And what we see is actually quite nice in the sense that it remains pegged very it pegs fairly quickly towards the $1 peg, and this is independently This is independently of the market scenario. Now, of course, in scenarios with a lot of volatility or scenarios where things are not going too well, there might be some more variability in how, or it can be like more spiky, right? Like it's not perfectly pegged to one. It can variate around it, but it goes back to it fairly quickly. And we can also simulate things such as how often simulations occur, the amount of simulations that occur during different market conditions. So we can see, for example, that in a high volatility market, there's much more liquidations than in a bullish case or a base case. We can also simulate different scenarios on how the number of chokes behave for each market condition. And on top of this, another thing that we did was we tested many different other scenarios. So we tested scenarios where the fill price drops by like 2% or by 50%, 90%. We injected depeg events. We simulated events where fill oscillates on a given range, or where there's a mass minting of USDFC, stuff like that. And in all of these scenarios, what we observed is that the price of the USDFC remains pegged. It pegs relatively quickly, and it's robust. And you don't have to take my word for it. I will post the simulation links at the end of the presentation so you can play with them. Another experiment that we did was going back to this collateralization rate, asking, okay, is 110%, the one that Liquidity currently has, is this enough for Filecoin? And what we did, or for a Filecoin-based CDP stablecoin. So what we did was, using our simulation environment, we tried to estimate the probability of having a liquidation inside a 10-block span. So basically, the probability that the price of fill would decrease more than 10% in a 10-block span. And this is a very small number, right? Like here we have that is around 0.2%. And we can also test it based on historical data, right? Like we can take fill price data on a block by block basis, and we can see how likely it is that it would decrease by more than 10% in a given time interval, right? So in 1 block, 2 blocks, 10 blocks, and 100 blocks. And what we see is that even for a 100-block interval, which is fairly significant, the probability of having a decrease in price that is so large that it might create a misliquidation, right? That it would make some positions be worth less than the 100% of collateralization is very, very small. It's about 1%. And this is before taking into account that this is just the probability that the price drops. If you have a liquidation bot that is fairly active, that is, that acts within a 100-block span, this number becomes even smaller. So the take-home message here is that this parameter, which is perhaps one of the most critical ones, is fairly safe, assuming that that we can have liquidation bots, but this is quite a mild assumption, because there's an incentive to have them, both in terms of safety and in terms of profitability. Okay, so some finalizing remarks. So what did we do? We developed a liquidity-style CDP stablecoin model for Filecoin. We then built a full Monte Carlo simulation capturing full price dynamics, row operations, stability pools, and AMM-driven peg adjustments. Why do we need this? Well, Filecoin has unique block times, as opposed to different block times. That's what I meant. Different market depth, different volatility than ETH, and we wanted to be like extra sure that what we have here is safe to use, right? That it will be pegged to 1. How did we test it? We ran hundreds of thousands of simulations on different market conditions. We created this whole methodology that you can play with to test even other market conditions, and in all of them we saw that the protocol acts as intended. And yeah, we observed that peg holds extremely well, and under the simulated scenarios, and that 110% collateralization rate is sufficiently good for our purposes. And with that, I finish. This QR code takes you to the GitHub repo with the simulation, where you can see the experiments that I talked about, as well as many others. Thank you.